of queries, but I won't do it. There is another lecture by another professor on database management systems where he tried it. I also repeated, and he's right. So basically, you can tell, for instance, to PostgreSQL to drop all the indexes, all the tables, everything, and then run the query, and everything will be read from the disk. So it's not only an thought experiment. You can really, if you have data, you can really perform it. But you will have a bit different results for sure. But this is like estimation. So you have 1,000 megabyte to read. Now, what we are doing here? You remember this number, 1 gigabyte. Now we move to the next slide, and here 7 gigabyte must be read. Why it's like this? The idea is of calculating everything what is here is we did the following. We put all the tables that we have inside a single mega table. So table that contains all possible combinations, all possible variants of the previous constellation with the relationships and the data. And by simply putting everything in one table, we got 7 gigabyte. So it's 7 times more data occupied by this mega table in comparison to previous 5 tables. What does it mean? It means if we get back to the idea that the operation that costs the operation on the data that costs you at most, it's reading from the table. Reading from the disk. And if you have to read 1 gigabyte or if you have 7 gigabytes, it's a huge difference. So I hope I could sort of explain you at least the drawbacks of putting everything into a single table. And could we also argue why too normalized data could be a dangerous approach due to different complications, due to complexity of the SQL queries. Now we use the same sort of strategy, or we want to run the same query. We want to run the select some revenue, but now we are going to use well known to us start schema. So we can recognize the start schema. It's nicely drawn for you. In the middle, fact table, around dimension tables, everything is perfect. So what does it mean? So to go to the branch now via the joins, you don't need to traverse all the tables. Why? Because it's directly connected to the fact table. Not a drawback, but rather you have to pay for this direct connection. Paying for this direct connection means only that you have a branch ID here, for instance. So you simply add a column that connects it to the branch ID. It's obvious, but it's like still, but you have to store. You have to store somewhere. Nothing is like happening on its own. But still, it's believed that you will have less joins. Data model is easier to understand. The amount of data to be read is less. So I extra mentioned it's believed to be that it's less joins. And why it's believed to be? Because it depends on the usage. You can also write a really complicated joins using this structure. But I think it's really a fact that you can say the data model is easier to understand, at least for you now, because you're hearing me speaking about the fact tables for the last 1.5 hours. So now looking at this model, you'll understand, okay, this is a start schema. No explanation. I know what is behind it. Now I'll do the same process we have the data, we have the same calculations here, we have the same query. I'll just skip it. And now what we see here, the number, it's less than 1 gigabyte. How it was possible? It was possible due to the reduction of all those unnecessary connections and to some extent to this normalization that played a good role for us, or played. Then we can also do the following trick. You remember that I spoke to you about the degenerating dimensions, where you put some dimensions there without IDs directly inside the fact table. Here we have a bit different approach. We just try to sum up the dimensions. So then we have even less data. And this is exactly the trade-off that you have to be aware, or that you have to like sort of know about. So sometimes you can really combine some dimensions. It depends on their size and the queries that you are running on them. And it's hard to say you in advance what kind of technique you should approach in order to have the best possible performance. But if we knew the answers, and if the answers were really easy to have and easy to apply, then we'll have no business intelligence and no analysis, because anyone would do that. So it's like knowing this information and applying those rules, and at least knowing where you have to, what you have to look for, will be a huge benefit for you, for sure. I could say, okay, there is a famous website, use the index look. I think it's from the German guy. I could just simply fire this part by saying always use the index and you will be fine. It's not true. If you have really complicated case, then only using the index won't save you. So then let's sum up some start schema principles. Joins are expensive, so try to avoid them, but still they're really useful. Why? Because from the perspective of flexibility and ability to read the data, they're really, you can't avoid them. If you have ability to avoid, try to do it, but you can avoid. Having a big table to have all the data makes no sense. Only in some cases it could make sense, but in this particular situation, no, it makes no sense, because you saw the size, it will grow, and as long as you will have new entries, it will grow endlessly, and you will have really bad performance of the database. Performing joins with a small dimension of tables is optimal. I didn't show it to you explicitly, but I will show you a mechanism how you can prove it later on your own. Performing a full table scan can be done on the fewer rows. So like if you don't pre-select or pre-filter the values using all the techniques the database offers you, just imagine that you don't have database, simply files, mega table, then you have to do the full scan of the table. And this is going to be a disaster. There is also a nice trick. I don't know whether you have heard about it or not. You can use so-called reaggregates. So like I have a couple of minutes left, but I still want to use the time to finish the lecture. Stay with me, and yeah, I think I need a couple of minutes because I have some important aspects that I want you to know. Materialized views are really amazing feature of the database. In case you speak, so it's a normal view. It's usually stored inside the database SQL query that you don't need to run every time. So it's stored there and it's run under query. And if you use it as materialized view, it will be sort of virtualized or a copy of the table, which is not as a table, but as the view. Oh, it's complicated. It means basically, if you have a materialized view inside the database, the values that you fetch from the materialized view are simply read from the table, read from the disk, from the memory, from whatever. There is no joins running there, despite your view contain joins. So materialized view basically means run the query, save the results as the table, and deliver me the results of the query when I ask for you, when I ask you for those results. When it's helpful, you have reports. You can run those reports over the night for a couple of hours, and then you will, after your ETL is completed, data is published, blah blah blah. You run the reports, create a materialized views or update them, and then next day your reports that are based on the materialized views are going to be fast because no joins are going to be performed. The data will be simply fetched. So I hope. And of course, use the indexes properly. I'll skip it. This is also where close to filter. Now, we spoke about the not ephemeral, but about the examples that we can't sort of test. But there is also inside the database, there are a functionality to understand the cost of the function. There is a possibility to execute cost of the function, sorry, cost of the SQL query. There is a possibility to execute the query, but you can also say, hey, database, don't run the SQL query, give me a so-called plan of the execution and try to estimate the costs. And in the PostgreSQL, you can achieve it using the explain analyze, and you will get something really cryptical at the end. And this is also the difference between the open source and the proprietary database management systems. They implement the proprietary database management systems implement this explain functionality to analyze the queries a bit better. I mean, they implement it better because it's what the DBAs, database administrators, or the people who are doing the analysis daily are using. But still, I want to show you the explain analyze using the SQL. So this is the query. It's from the exercise 4. I just took it, and it's just some joins for sure because we spoke about the joins. So the fact table are going to be joined with the customer. And what you got at the end, I think it's not readable, but this is a cost function, how the database sees it. Yeah. So you see those numbers. So this is actually the cost of the database can only estimate the time of the query processing. It can not really say you, hey, this query will exactly run for 2 seconds. So it's not possible. Why? Because of the isolation, because you may have different clients that interfere and reduce the performance of the database. That's why all the costs that you see here are estimated and not real time. You never get, so this query will run 5 seconds and you will always have 5 seconds for this query. This is not possible. But I just want to mention you what kind of complexity here. So here you have a sort, you have a group aggregate, then you have a again sort, then you have hash join, then you have a sequential scan, then you have hash, and then you have a SQL sequential scan. So it's like going to the bottom and then going up, and you at the end get your results using the limits. So I won't explain you this plan of the SQL. I just want to show you the way how you really could analyze the query of a real query. For PostgreSQL, as long as it's an open source, there's some tools the one can use. I generated this nice visualization that it's hard to understand without knowing the PostgreSQL. But still, I wanted to show you the source, explain dps.com, so you can use this resource later on if you need to visualize in a nice way really the execution plan of the PostgreSQL query. So, and just a second. Okay. And here we have the same information, more meaningful. So you see, we have a node. It's like execution part of the query. So it's just internal stuff of the database management system. And if you look at this part, you see that hash join took almost 30% of the time, and sorting took over 30% of the whole time, yeah, of the query. So it's like this is sorting and hashing and joining. It's the most heavy part for the database management system to perform. Yeah, I already mentioned those examples or those benefits. Joining big tables is expensive. Don't forget about the problems with slowly changing dimensions, where clause in the big tables are expensive as well because of full scan. If dimension table is too big, it's growing enormously with the same pace as fact table, it's better to split it. So it's how a typical. This is a particular example of how. Sorry, I'm just over the time. Just let me finish, so we'll get to this topic next time. So this is an example how a dimension table could be splitted. So again, you don't always have to do it, but if the dimension table is growing due to slowly changing dimensions, or due to ETL, or due to the nature of the process, with the same pace as the fact table, it's better to split it. Better to do something with it due to the fact that then if you don't do it, then you will have two fact tables to deal with. So cost of join summary and exactly logic modeling. So it took a bit more time today, sorry. I hope you enjoyed the lecture. I uploaded it already to the cloud. I have one question left for you, but I won't ask you that question. It's about the materialized views. Just keep it in mind that is an instrument if you need such functionality. Do you have questions? If you don't have questions, then thank you for your time. Happy New Year again, and see you once who is attending the exercises on Friday this week. Have a nice day.